Thanks for the introduction, and it's great to be here. And you probably saw the first instant that why do I need glasses? Because I can't find a clicker that's behind the table. It's a problem that my wife keeps mentioning all the time, that I have some sort of a man look that's not able to see the most obvious things. So my talk today is going to focus on why we don't need big data. So with big data, so it's one of those things that everybody loves to talk about at conferences. But it doesn't really mean a lot on its own. Some people say that big data is like the Rorschach's test for the tech industry because it means something different to everyone. So I've come not to celebrate big data, but to bury it. At least the simplistic notion that big data on its own is something that's meaningful to all of us. Because we need a fundamental rethink on the way we interpret and harness big data. We are all living through an extraordinary time. It's an AI revolution, but it's also an evolution. The first generation, or the first wave of AI, was all about numerical inputs. I still remember my first day at university in India, where I got my first scientific calculator. And having struggled through log tables for many, many years, it was pure magic. I even thought those calculators were intelligent. The second wave of AI is all about deep learning and deep neural nets, which have, again, shown a lot of promise with image classification. So you can classify the images of your cats and dogs very easily, and also for playing board games. But when we really have strived for benefits of deep learning and deep neural nets for large-scale businesses to solve enterprise-grade problems, they have failed. That's where the third generation of AI and machine learning comes in, which is all about using AI and machine learning to help enterprises and businesses make better decisions. And this is where we get a combination of probabilistic modeling, like Gaussian processes, different learning techniques, like reinforcement learning, and using econometric models to get enterprises to make better decisions. And this, we believe, is going to be the massive opportunity that promises to transform our lives, our industries, our companies, and the world around us. And this is why Prowler was founded, to create the infrastructure to continue driving forward the AI revolution and to help leaders and organizations make better decisions. But to help us succeed in our mission, we need to start by fixing big data, because that's where lies the unfortunate reality. Generally speaking, big data sucks. And so do the systems we've built to interpret and harness that data. Yes, we live in a data-driven age, and half the presentations over the next 3 days will talk about how we can use data to transform the world. There's no doubt about that. But the truth is that a lot of time, organizations, businesses are totally not set up to make most of the power of data. Data is of poor quality, it's sporadic, it's missing, and it's poorly recorded. And also, businesses face unexpected events and uncertainties that challenge their existing systems. And business decisions have a massive impact across the organizations and the infrastructure. And they are not isolated to a single state, but are really a result of a chain of multiple states. And also, the way incentives are designed for employees, organizations, or customers needs to be rethought. Now, the limitations of the current approaches of data are not just that just some of us think of as an abstract problem, or things that only nerds like us think about, but they do have a huge impact on organizations, and here is a very tangible example I'll walk you through. So let's consider a delivery company that is concerned with a business of operating a fleet of vehicles with a set of pallets that trucks need to collect and deliver to the customers. The number of assets, so the number of assets to collect at the retailer side is unknown, so that's here actually, and which generates inefficiencies and higher transportation costs. And also the number of assets moved between the customers and the retailers are not tracked. The number of assets available to issue to the customers is not known with reasonable certainty and could result in unnecessary long-distance travel. So anybody operating in any supply chain business will recognize these problems. And the supply chains that we deal with are not as simple as this figure shows, but it's probably something like this, or probably orders of magnitude more complex than this too. So what's the solution? The typical IoT big data response just doesn't work here. So if you ask the IoT evangelists, they will ask you to put a sensor on every pallet and just track them. But let's consider the challenge of managing such a large-scale delivery operation. So the problem that we deal with is of nearly 400 million assets, of which nearly half of them need to be repaired every year. So even with the cheapest GPS IoT sensor you could find, which is typically $10 a pop, you're looking at a capital investment of $4 billion in year one and $2 billion every year after. And that's just for the sensors alone. So the financial, logistics, and environmental costs of installing these are just crazy. Simply won't work. In short, you cannot IoT yourself out of this problem, or for that matter, any supply chain problem. So here's a slightly different approach, one that's sustainable, doable, and makes use of smarter approaches to AI, and which has also been proven in the field. So what we have here is historical data of the trucks that come and pick up the pallets at the customer side. So the green dot here represents a truck coming to the customer, finding 390 pallets, and going away happy. So that's classified as a successful collection. Whereas the red dot here represents a truck coming and finding no pallets and going back not very happy. So with the historical data that we had, and I must point out, we did not have millions of data points. We did not even have hundreds of data points or thousands. We literally had to start with tens of data points. Using Gaussian processes, we were able to build some forecasting models that allowed us to understand or develop or predict the ground truth, which is really the actual number of predicted pallets at the retailers. And in the UK alone, we are talking about close to 50,000 retailers. So it was a massive problem where we really had to go down individually and actually model that. And using these forecasted predictions, we ran our systems in an actual operating environment for 8 weeks and we ran them in parallel to existing world-leading supply chain optimization platforms. And the results were actually quite dramatic. Not only were we able to show a 62% reduction in the failure rate of collecting the pallets, but we were also able to show up to a 28% improvement in asset utilization. And the impact of this to the business was tens of millions in savings every year. And all this without any capital investment in IoT or big data, zero. We're not against data. If we get more data, it's fantastic. We can always improve the models and get more improvements. But the key thing here is that most of the time, companies actually don't have the data, and not making a decision is not an option. But the question is this enough? Because obviously, one of the best ways to reduce collections or failed collections further is to only go and collect your pallets once a year. So you'll be absolutely assured that there are lots of pallets at your customer, and your truck will always be full. The only downside of that is that the company will not make any revenues because you won't have any pallets to send to your customers. So you can't think in terms of solving the problem as a local Optima that is only focusing on the failed collections, but you have to think in terms of a global Optima, that how do you build an optimal system that works for the entire organization as a whole? And that's where dynamic trade-offs come in. So here is an example of the further evolution of the solution that we built, which now moves to a more dynamic trade-offs and using global Optima. And this is, for the sake of simplicity, on 2 dimensions. So with this model, what we were able to show is that in times of very high demand, we could move towards more aggressive schedules of collecting the pallets, so which is here, with a very low risk of failed collections. But at the same time, in times of low demand, where the demand of the pallets were not there from the customers, we could slow down the collections, let the pallets build up at the retailers, and thereby reduce our transportation costs. Now, of course, it's fairly kind of easy to think about that for one particular retailer, optimize that, make phone calls. But when you're talking of a few 100,000 retailers globally, it becomes a much more complex challenge. So the key was to be able to automate it and run it so that at any given time of day or night, the systems could be queried with respect to any particular retailer, and the delivery schedules could be managed and updated. What we are working on now is to move these 2-dimensional trade-offs to tens of dimensions, and over the next 2 years to hundreds of dimensions. Because ultimately, any business problem is really a business problem about trade-offs, which are high-dimensional. And we believe that has the potential to unlock billions of dollars of value for large enterprises. So this is another approach to serving businesses, the one that takes big data and replaces size with smarts. If we want to continue making progress in the AI revolution, we need to prove and move beyond simply evangelizing and generating big data and harnessing new tools that can take this genuinely usable to leaders and organizations. And 5 minutes of looking at the headlines today would be enough to remind all of us what happens if we don't invest in making smart decisions. So let's start by rethinking the data we need to make those decisions. And my bold prediction is that by 2025, AI for decision-making will drive the world economy. Thank you.